All right. So, introduction to mechanical engineering. So, before we get into the details of mechanical engineering and what the engineers do and other intricate details, right? So, let's also try to think how it all started. Yeah. So, mechanical engineering is one of the oldest discipline among all other disciplines, right? And for the ages, mechanical engineering has been the fuel for industrialization, right? So for decades together, this particular discipline has been key for the industrial growth as well as to enhance the life of the people, right? So mechanical engineering is a professional discipline, yeah, wherein it applies certain physics, certain underlying principles for the end applications which touches the life of the people. Very simple. This could be energy or motion for that matter, or if you're working on the fluid domain, yeah, it could be Navier-Stokes equation or Bernoulli principle, right? So there could be a set of rules and procedures through which we developed the end products. So these underlying physics are used to develop the systems through various stages. Yeah. So it's not we use the physics in one stage and we develop the product. So there are various stages from starting till end which uses the engineering physics, yeah, for a successful outcome of a product. So these various stages, for example, could be your design stage, analysis stage, manufacturing, after sales, service, so on and so forth. Yeah. So at each and every stage, yeah, we apply engineering physics, we apply the project management principles, yeah, to make sure the customer requirements or people requirement, yeah, it's converted into a end product. Okay, so applications of modern day mechanical engineers. So before we get into this topic, let's also think what did the mechanical engineers do in the past? So predominantly, if you see, mechanical engineers were mainly focusing, of course, on the design, but a lot of thrust were given on the production engineering in the past. So people were predominantly studying the methods of manufacturing, various techniques, how we can produce the product in a cost-effective way, in a better quality, right? But the modern day mechanical engineers have a new sort of gameplay, right? So they have to work in tandem with other mechanical engineers as well as multidisciplinary teams. That multidisciplinary teams could be electrical engineering, electronic engineers, or computer science engineers, or off late with artificial intelligence or machine learning engineers, right? So this new way of working, yeah, is very important for the mechanical engineers, yeah, to extract the synergies with this interdisciplinary teams for the success of the product, right? Now coming to this synergy, yeah, this is the reason why the mechanical engineers has to break the silos and come out of only a mindset of production or a mindset of design. So basically the mechanical engineers has to think from the start the idea is originated till the product is delivered to the customer. Yeah. So they have an hand on each and every stage of a product life cycle. Yeah. So as I said, mechanical engineering is now an interdisciplinary domain. Yeah. You can't literally see a mechanical engineer working only in silos and focusing only on a pure mechanical topics. Yeah. But now the scope of the product has increased and this requires mechanical engineers to focus on a lot of problems outside the scope of what he or she was handling before. So coming to the problems what the mechanical engineers were solving, okay, initially if you see the industrialization, right, we were focusing on uh, steam power, for example, and now we are talking about electric, nuclear, hydrogen power, so on and so forth. Yeah, but initially we wanted, we are focusing on, say for example, an automobile. Yeah, we wanted to move people or move cargo and goods from one place to another place. Yeah, of course the scope was not so much like what we are having in the current days, but rather those physics or processes has set an example or set a benchmark for us to where we can take it further, right? For example, imagine what we were focusing on automotive. Yeah, so basically we were intending to move people from one place to another place, right? But right now we are talking about emissions. Yeah, we are talking about green mobility, we are talking about sustainability. Yeah, we are talking about hydrogen cells. So there are a whole set of new technology where engineers are working on. Yeah, so for example, if you see some of the solutions where we are working on as a mechanical engineers, healthcare. Yeah, I can't imagine what was a role of a mechanical engineer in the past in healthcare. Of course, the scope was there, yeah, but it was pretty limited. But today, if you think about healthcare, you have mechanical engineers working on building huge diagnostics equipments or instruments. Yeah, mechanical engineers like you are working on building robots for robotic surgeries in the healthcare. Yeah, so there is a new set of scope which has emerged because of the advancements or the requirements to make the life of the people much better. Let's take about energy. In the past, energy we were mostly focusing on internal combustion engines, for example, or coal, yeah, or hydro energy. Today we are talking about nuclear energy, right? And we are talking about electric energy. We are talking about electric vehicles. Yeah, we are also talking about energies from hydrogen fuel cells, right? So there are a lot of sustainable energy solutions which people are focusing right now. Say for example, solar energy, wind energy. Yeah, so these kind of renewable modes of energy are also taking a predominantly a
Mana,
center stage where we talk about the
mana,
sustainable energies, right?
today,
Computer science or computers for that matter.
ah,
Yeah, remember the olden days where you used to have floppy disks,
yes,
or even to
yes,
have a,
okay,
a small MB of data used to have a bigger storage. Now we are easily talking about
okay,
terabytes of data very easily, right?
yes,
And with the advent of the increase
mm,
in storage, an increase in computing, it also leads to increase in complexity. For example, huge supercomputers emits a lot of heat, right? So it's also important that
और
you
सबूत भी तो हमारे पास तो बच्चे
have a
हैं
higher life for the computing or the electronic components, yeah, by removing the heat. If you don't remove the heat properly, you are reducing the life of the components, right? So it's very important for the mechanical engineers to work and design innovative solutions to ensure that heat is not stuck in a single place.
हम्म,
May it be a
सही
supercomputer
है
or any electronic gadgets for that matter. Now let's come to the space. Yeah, I think in the past we were developing, rockets, uh, and we wanted to put people into space. We wanted to put equipments into space. Say, for example, satellites. But today, if you see, let's take an example of India, right? We are one of the cheapest uh, uh, service providers in the world to put the satellites in orbits. Yeah, I think it's something not many countries have achieved. Yeah, this is also one of key success of not only the mechanical engineers but also the interdisciplinary um, uh, engineering, right? So let's take an example for that matter about Mangalyaan project, right? So this is something which the Indians could achieve yeah, at a fraction of cost compared to the other space agencies. Let's talk about mobility now. In mobility, in the past we were focusing on moving people from one place to another place, yeah, and reducing the dependence on animals for mobility, right? Say for example horse carriages or bullock carts for that matter, right? So historically, we were working on the development of internal combustion engines. I think ICE or internal combustion engine is one of the biggest invention, yeah, which transformed the mobility. Yeah. Today in mobility, we have mechanical engineers like you working on electric vehicles, working on hydrogen fuel cells. Yeah, people are working on autonomous vehicles. So coming to the autonomous vehicles, we are talking about a driverless vehicle, yeah, a self-chauffeured and a self-driven vehicle which can take people from point A to point B. Very simple. We couldn't imagine these kind of technologies in the past. Suddenly internet is fueling a lot of these growth because all of these segments, whatever we spoke about, right, it needs a lot of data. It needs high speed data transfer from one machine or one component to another component for that matter. Yeah, so internet for that matter is fueling the growth of even the mechanical engineering. Yeah. So coming to the domains or the scale of problems what mechanical engineers work on, they work from nanoscales, yeah, nanometer, 10 power minus 9 meter. They work on such a small scale till possibly a kilometers or a mile scale. Yeah, I can easily quote some example of nano robots. People are working on building nano robots which can get into the uh, human body and destroy the cancer cells. I think there are a lot of research working or a lot of research
नहीं
taking
घुसने की
place,
जरूरत ही नहीं
right?
अपना
For example,
स्लो जा
microelectromechanical systems we used to call as MEMS system.
हाँ
Yeah,
और क्या
so we have MEMS which is the size of a micrometer.
तू तो
So
दिमाग क्यों लगा रहा है
whatever components or whatever products you're talking about in MEMS, yeah,
फिर
size of
सही बात है सही
micrometers.
बात
Yeah,
है
it's a few
हाँ
micrometers for that matter. You have MEMS robots, you have MEMS sensors, and these sensors, yeah, are used in wide range of applications, right? And you're talking about mechanical engineers like you, yeah,
मैंने
working
मेरे
on
में मैंने
building
डाला ही नहीं कोई सा भी नहीं डाला मैंने
say pipelines from continent to another continent. Yeah, we have pipelines for gas, for petrol
अरे
or diesel, or for
अपन तो
crude oil for
मेंशन ही
that
नहीं थे ना
matter,
अपने
right?
डाला ही नहीं
And you have mechanical engineers
देख
working
मैं देख
on
ले अगर कभी
building
मेंशन ही
huge
मेरे डाला था
equipments, right? So
तू देख
the
लेना
scale of problems what mechanical engineers, yeah, it's
अपन तो
very
बाहर ही
wide.
ऐसी
Yeah, starting from nanoscale, or for that matter much smaller than that maybe, yeah, till the macro scale, starting from biological domain till the space domain. All right, so what are the problems mechanical engineers are trying to solve,
इस हद तक
right? So mechanical engineers are trying to create a huge knowledge bank, knowledge base, through the application of engineering physics or the underlying principles to create a cost effective or innovative product, right? So the research and development is key for the mechanical engineers, yeah, for creating this knowledge base, yeah, and they also create this product through construction, control management, sales of devices and systems. So these are some of the areas where mechanical engineers has a hand in it, right? So as I also discussed in the previous topic, the mechanical engineers are trying to solve
हाँ अभी राहुल ने फोन
a
करा था मुझे बता
huge set
रहा
of problems, yeah, which is relevant to the present and also
कौन
more
बोल रहा
relevant
था
to the future in the
तुम्हारे
domains
अरे प्रिंसिपल बोल
starting
रहा
from healthcare till the internet. right? So if you see the picture here, yeah, we talk about the industry 1.0 till industry 5.0. Yeah, of course, in each of these industrialization, mechanical engineers had a specific problem to solve. Let's touch upon that in the coming session. Yeah, but nevertheless, mechanical engineers are attempting to solve a whole new set of problems, which
Kind
is
of, yeah.
which is having a bigger scope, and they have to work with cross-functional teams.